Okay, Bismillahirrahmanirrahim. Assalamu alaikum, class. The topic of discussion in this class is instruction set architecture and CISC versus RISC. So today we are going to study the ISA instruction set architecture and compare two major types: CISC complex instruction set computing and RISC reduced instruction set computing. The key idea here is how CPU communicates with software, right? Every program that you write, चाहे वो किसी भी लैंग्वेज में हो, वो सी लैंग्वेज में हो, जावा में हो, या पाइथन में हो, या किसी और लैंग्वेज में हो, it eventually needs to be understood by the CPU, क्योंकि we know कि इसको CPU ने execute करना है. So the way this communication happens affect the performance, the power consumption, and the efficiency of the CPU. Right? ये तीन factors इसमें involved हैं. So this topic is very important in understanding how computer actually works internally. Right? So let us start the detailed discussion. What is an ISA? अच्छा, ISA is like a bridge. ठीक है, दो चीजों के दरमियान ब्रिज है। और जैसे मैंने पिछली स्लाइड में बताया कि वो दो चीजें क्या हैं, कि एक तरफ हमारे पास सॉफ्टवेयर है, ऑन वन साइड वी हैव सॉफ्टवेयर, इट विच मींस वी हैव प्रोग्राम्स, ऑन द अदर साइड वी हैव हार्डवेयर। अब वो हार्डवेयर क्या है? दैट इज द प्रोसेसर और द सीपीयू। सो वी हैव टू रन दी सॉफ्टवेयर और प्रोग्राम्स ऑन द सीपीयू। सो आईएसए इस प्रोसेस को इफेक्टिव बनाने के लिए एक्ट्स एज अ ब्रिज। तो अब ISA डिफाइन क्या करता है? What instructions the CPU can understand and execute. ठीक है, ISA instruction set architecture defines what instruction, कौन कौन सी instruction CPU understand कर सकता है and execute कर सकता है. You can think of it as a contract. ठीक है, ये एक type of contract है that software must follow ISA rules. CPU guarantees execution of those instructions. Which instructions? ठीक है, वो instructions जो कि हमारे ISA ने डिफाइन की हुई हैं, या जो हमने ISA के थ्रू डिफाइन करवाई हुई। अब हम देखते हैं कि ISA में क्या क्या चीजें होती हैं. लेट्स ब्रेक ISA into its components. The first one, ISA क्या डिफाइन करता है? It defines basic operations that the CPU can perform, like add, sub, ठीक है, एडिशन, सब्ट्रैक्शन, लोड, स्टोर ऑपरेशन। तो हम इसको यूं कहेंगे, दीज आर दी वर्ब्स ऑफ द सीपीयू। अक्सर बुक में ऐसे लिखा जाता है. द सेकंड थिंग दैट इट डिफाइंस इज द रजिस्टर्स, एंड we will be studying registers in the upcoming classes, but at least we know that registers are small, very fast memory inside CPU used to temporarily store data, like they are like pockets to the processor, जैसे मैंने पहले भी कहा था. थर्ड थिंग जो ये डिफाइन करता है कि इंस्ट्रक्शन का फॉर्मेट क्या होगा, हाउ इंस्ट्रक्शंस आर गोइंग टू बी रिटन. ठीक है, एंड इसके अलावा जो नेक्स्ट चीज है, दैट इज द एड्रेसिंग मोड. वी हैव डिस्कस्ड इट इन द प्रीवियस क्लास दैट हाउ द ऑपरेंड्स आर गोइंग टू बी एड्रेस्ड, how the CPU finds the data in the memory. We have different types, we will be studying it, direct, indirect. We have different types of addressing modes. ठीक है, so that is about the ISA कि ISA क्या है, और ISA के अंदर इंस्ट्रक्शन सेट आर्किटेक्चर के अंदर कौन कौन सी चीजें जो हैं वो डिफाइंड होती हैं. तो वो चार चीजें हमने जो है वो पढ़ ली. सो ISA इज नॉट जस्ट इंस्ट्रक्शंस, इट डिफाइंस द एंटायर स्ट्रक्चर ऑफ कम्युनिकेशन. ये बहुत इंपॉर्टेंट पॉइंट है क्लास. ISA is not just a set of instructions. You are not going to define it like a set of instructions. It defines the entire structure, जैसे मैंने कहा. It defines the operations, it defines the registers, it defines the instruction format, and it defines the addressing modes as well. And all these four things are related to instructions, and when all of these are combined into a single thing, then that thing is referred to as ISA, right? Okay, so ISA in action, a simple example. Let's understand this practically. We write program in, for example, any high level language. Let's suppose हमने C में program लिखा है या Java में. But the fact is, CPU does not understand this. So what happens? A compiler converts your program into ISA instructions. क्योंकि पिछली स्लाइड में हम ये पढ़ के आए हैं ना कि ISA defines those instructions and those operations that can be performed and understood by the CPU. So now when you write a program in any high level language, right, that program is basically converted into ISA instructions by the compiler. ठीक है, अब जैसे आप देख सकते हैं एग्जाम्पल के तौर पे यहाँ पे आपको एक सैम्पल इंस्ट्रक्शंस दी गई हैं. लोड R1, A, load R2, B, add R3, R1, R2 and store C, R3. अगर आप इसको स्टेप बाय स्टेप देखें so it is saying load A into R1. A, like for example, A is a variable and R1 is a register. Then it is saying load B into R2, and then in the third instructions it says add them and store in R3. ठीक है, add R1 and R the contents of R1 and R2 and store in R3, and then save the result into C. So this is how simple operations happen at machine level, right? So I repeat के आपने जो instructions लिखी हैं वो आपने high level language C या Java में लिखी, compiler ने उसको ISA language में या ISA instructions में convert किया, ठीक है, और ISA instruction की example जो है वो मैंने आपको दी है, ठीक. Now we move to the first architecture, CISC, very important class, complex instruction set computing. The core idea behind CISC is that one instructions can perform multiple tasks. So instead of writing many steps, you write one powerful instruction. Why we are calling it powerful instruction? Because it has the ability to perform multiple tasks. So CISC is an architecture where one instructions perform multiple tasks. The goal is to do more tasks per instructions, reducing the total number of instructions needed in a program. क्यों? क्योंकि जब एक इंस्ट्रक्शन ज्यादा काम परफॉर्म कर सकेगी, उसकी बैक एंड पे मल्टीपल ऑपरेशंस परफॉर्म हो रहे होंगे या हो सकेंगे, तो आपकी जो टोटल नंबर ऑफ इंस्ट्रक्शंस हैं प्रोग्राम में वो रिड्यूस होंगी. ठीक है, थिंक ऑफ इट एज अ कैलकुलेटर विद बिल्ट इन फॉर्मूलाज. ठीक है, जैसे कि एक फॉर्मूला जब आप कैलकुलेटर में अप्लाई करते हैं तो उसके पीछे कई ऑपरेशंस परफॉर्म होते हैं. So although you are applying one single operation, but at the back end it contains many operations. या आप एक मल्टी फंक्शन प्रिंटर की एग्जांपल जैसे कि मैंने यहाँ पे दी हुई है, या मल्टी फंक्शन मशीन कंबाइनिंग प्रिंटर, स्कैनर एंड कॉपियर इन वन डिवाइस. ठीक है, so one button multiple operation, and that's exactly what CISC does. तो CISC के फीचर्स क्या है कि लार्ज इंस्ट्रक्शन सेट है हमारे पास, ठीक है, और लार्ज इंस्ट्रक्शन सेट का मतलब कि ज्यादा इसमें इंस्ट्रक्शंस हैं और हर इंस्ट्रक्शन जो है वो कम्प्लेक्स है और पावरफुल है, बल्कि इसको यूं कहना चाहिए इट्स पावरफुल. Why? Because it's powerful, because it's complex and it is performing multiple operation. A single instruction is performing multiple operations. And the second feature is कि it is like multi-cycle. ठीक है, large instruction, we have large instruction set and we have many powerful instructions and it is multi-cycle execution क्योंकि एक instruction complex है, ठीक है, उसके अंदर multiple operations perform हो रहे हैं. So one instruction takes multiple clock cycles to get executed. ठीक है, and प्रोग्राम का साइज जो है वो स्मॉलर है बिकॉज वी नीड फ्यूअर इंस्ट्रक्शन बिकॉज ऑफ द फैक्ट कि हर इंस्ट्रक्शन जो है वो कॉम्प्लेक्स है और मल्टीपल ऑपरेशंस परफॉर्म कर रही है, तो प्रोग्राम का साइज स्मॉलर होगा. ठीक है, और आपकी जो नंबर ऑफ इंस्ट्रक्शंस हैं वो पर प्रोग्राम वो रिड्यूस होंगी. सो सिस्क फोकसेस ऑन डूइंग मोर वर्क पर इंस्ट्रक्शन. ठीक है. Okay, so now let's have a look at the example and advantage and disadvantages of CISC. So let us see an example which is written over here, which is a pure example of a single instruction having multiple steps. It says at A, comma, B, and we have an arrow C. Now this single instruction, what it does, it loads data, it adds value and stores result. So see, there is a one single operation, but behind there are three different operations that are being performed. The data is being loaded, the values are being added, and the result is being stored. So अब इसके advantages हमारे पास क्या है? Obviously it's a shorter program, it saves memory, easier to write the code as well. And as far as the disadvantages are concerned, ये मैं आपको, it's not only about the advantage or disadvantage of this one single example, we are talking about the pros and cons of the CISC architecture. So disadvantage क्या है कि we will have slower execution, right? We will have complicated CPU design. अच्छा, why slower execution? Because it requires more cycles. Why complex CPU design? Because it's harder to design and optimize a CPU for complex instructions which can perform multiple tasks. And then we have poor pipelining. Now, pipelining is a concept which we are going to study in the future, but for now you need to remember कि pipelining के through हम आपके अपने प्रोसेसर की जो प्रोसेसिंग कैपेबिलिटी है उसकी एफिशिएंसी को बढ़ाते हैं, ठीक है? तो उसके लिए जरूरी होता है कि जो इंस्ट्रक्शंस हैं वो सिंपलर हो. यू विल रियलाइज दैट इन द पाइपलाइनिंग चैप्टर देन, राइट? Okay class, so now it's time to flip the idea and let's talk about the risk, reduced instruction set computers or computing, right? Now we need to understand the core idea behind risk, and the core idea is very simple: one instruction, one single task. Remember the other one, the CISC, in which one instruction could perform many tasks because it was a complex instruction. But over here, the instructions are simpler. One instruction, one simple task. So instead of one complex instruction, we use multiple simple instructions. Are you getting my point? Over there we had lesser number of instructions in a program. उसकी वजह क्या थी कि एक instruction could perform multiple operations. लेकिन यहाँ पे in the reduced instruction set computers we have more instructions per program क्योंकि one instruction can perform one single or simple task. So instead of one complex instruction, as I just said, we use multiple simple instructions. अब features हम इनके discuss करते हैं. We have small and simple instruction set. ठीक है, वहां पर हमारे पास जो CISC आर्किटेक्चर है उसमें जो इंस्ट्रक्शन सेट है हमारे पास, दैट इज क्वाइट लार्ज. इंस्ट्रक्शन कम्प्लेक्स भी है एंड नंबर ऑफ इंस्ट्रक्शन जो है वो ज्यादा भी है. यहाँ पे इन रिस्क वी हैव स्मॉल एंड सिंपल इंस्ट्रक्शन सेट. जो हमारा टोटल नंबर ऑफ इंस्ट्रक्शंस हैं इन रिस्क आर्किटेक्चर वो लेसर है, और जो हर इंस्ट्रक्शन है दैट इज सिंपलर, इट परफॉर्म्स वन टास्क. And because of its simplicity we have one clock cycle execution per instruction. वहां पे हमने ये डिस्कस किया था कि a single instruction could take more than one clock cycle because of its complexity. लेकिन यहाँ पे क्योंकि instruction simple है and one instruction is performing only one task, so that is the reason कि यहाँ पे जो execution है आपकी instruction की that takes one single clock cycle. ठीक है, लेकिन more instructions per program because instructions are simpler. So as I mentioned in the start as well, we will now have more instructions per program and register efficient. Now it makes heavy use of the registers because of having multiple instructions in a program, right? So because of the fast data access required, the use of registers would be really high. So as far as the real life example or analogy is concerned, so think of it as an assembly line in a factory. Turn by turn, everyone performs its task and the task then goes ahead. Okay? So each worker does one small task. A work moves fast because of specialization. Okay? So हर एक वर्कर जो है वो अपने काम का स्पेशलाइज्ड है, वो मल्टीपल टास्क नहीं परफॉर्म करता. जो एक टास्क उसको असाइन कर दिया गया है, वन सिंगल टास्क, so it receives the input from the previous person, it performs its task and then the task moves ahead to the next person. So it is like assembly line functioning. Okay, so risk, Simple instructions, more number of instructions per program. Okay, class. So let's talk about the advantages and disadvantages of the RISC architecture. Well, it has faster execution, obviously, because the instructions are simple and take one clock cycle. So the execution is faster. Pipelining, जो मैंने आपको बताया कि it is a technique for improving the efficiency of the processor, and इस technique को implement करने के लिए we need simpler instructions. So in the RISC, the instructions are simpler, so it is like more suitable for applying pipelining. We have efficient performance of the system because of the simple CPU design. And as far as the disadvantages are concerned, so as I have explained earlier, कि एक single program में we will be requiring more instructions because of the simpler instructions. So इसके result में the program size would increase, and more optimization of the compiler would be required, और memory भी ज़्यादा चाहिए होगी क्योंकि number of instructions जो हैं वो ज़्यादा हैं. अब आप यहाँ पे रिस्क की एग्जाम्पल देखें कि वहाँ पे जो एक सिस्क में जो एक इंस्ट्रक्शंस मल्टीपल टास्क परफॉर्म कर रही थी, यहाँ पे नाउ वी नीड 4 इंस्ट्रक्शंस. सो मल्टीपल सिंपल इंस्ट्रक्शंस रिप्लेस वन कम्प्लेक्स सिस्क इंस्ट्रक्शन. ठीक है जी. तो ये अब एक एग्जाम्पल है जिसके थ्रू आप कंपेयर कर सकते हैं सिस्क एंड रिस्क के आर्किटेक्चर को. इंस्ट्रक्शन रिप्लेस वन कम्प्लेक्स सिस्क instruction. ठीक है. So now this slide contains a comparison of CISC versus RISC in a tabular form. uh, as far as instructions are concerned, तो CISC में instructions ज़्यादा हैं. We have many instructions and we have complex instruction, while RISC has fewer and simpler instructions. The clock cycles, जो CISC की instruction है वो multiple clock cycles लेती है per instruction, और RISC में usually it takes one clock cycle per instruction. As far as program length is concerned, so CISC has shorter length because of a lesser number of instructions, and RISC has a longer program length. As far as memory usage is concerned, so in CISC we have lesser number of instructions, so lesser memory would be required, while CISC would require more memory. As far as the speed is concerned, CISC is slower, RISC is faster because of the better CPU optimization. Pipelining is very difficult in CISC because I have already mentioned that pipelining is a technique used for improving the efficiency of a program, and it requires simpler or shorter instruction which are normally supported by the RISC architecture. The design of CISC is complicated and RISC is simple. And then very importantly, we need to have a few examples. So the Intel x86 uses CISC, while the ARM and MIPS systems make use of the RISC architecture, right? So when to use CISC or RISC? Now let's move towards the conclusion. So CISC is normally used for PCs and laptops, where we have complex instructions, and where memory is limited. This is a very important point. While RISC is best for mobile devices, the embedded system, the high performance system, where the speed of the execution matters. Okay. Okay, so now let's wrap it up and let's move towards the conclusion. Uh, ISA, instruction set architecture, acts as a bridge between the software and hardware. यहाँ पे software क्या है, that is the program that is to be executed, और hardware क्या है, that is the CPU or the processor. ठीक है. Then we have CISC, fewer instructions and complex instructions, and RISC में क्या है, we have more instructions and faster execution. ठीक है. Modern trend क्या है? So as it is clearly written कि the modern technology is more like the RISC dominates the modern technology, especially in the mobile devices and embedded systems. But CISC is equally important, still important for compatibility. For example, जो हमारे पास PCs में compatibility का issue है, उसके लिए CISC is very important. So अगर मैं इसको बिल्कुल conclude कर दूं, if like you understand one thing from this lecture, it should be this, that CISC focuses on reducing the number of instructions. I'm talking about CISC, complex instruction set computing, while RISC focuses on increasing the execution speed. So that is about the lecture. If you have any question, any ambiguity, or anything, you please note it down, and you are always welcome to discuss. And I would definitely appreciate any question from your side. Thank you very much.